I'm going to attempt to sketch the parabolic function negative 1/2 x squared plus 4x minus 2 using all available methods. We can use the axis of symmetry to help us sketch the parabola. We can also find the location of the vertex, and we can even find the locations of the zeros where the parabola intercepts the x-axis. There's one other graphing method I want to use here too, and that's called a table method. So I'm going to start by setting up the table for a minute. The way it works is you pick some different x's that you want to plot in the left column. Then you plug those x's into the formula. And then we find an output height and put that in the last column. Now before I go to pick the x's that I want to work with here, I just want to know, where does the vertex happen? I want to find the axis of symmetry first, because that'll help me make good choices when it comes to picking the x values. So let's use the formula x equals negative b over 2a. Our b is 4, and our a is, for this parabola, negative 1/2. Okay, that's going to come out to an x of 4. So I can go ahead and sketch the axis of symmetry. It's going to be a vertical line. X equals 4. The axis of symmetry. Okay, so that helps me pick x values that I'm interested in here. Like, for example, I wouldn't pick negative 9 as a first x to graph, because I want to pick x's that are around 4 so that I can really see the curvature of this parabola and where it turns around and everything. I'm going to pick an x of 0. I'll do 1 and perhaps 2, 3, 4, and 5. Let's do those. Okay, so all we have to do is plug in the inputs that we chose into the function's formula. We can do that on calculator. The y-intercept, it's called, of this parabola is 0, negative 2. It's called the y-intercept because that's where our parabola touches the y-axis. Okay. Now let's try plugging in a 4 here real quick. That's a really important value for the parabola, because this is going to be the vertex. Okay, comes out to 6. All right, let's label that the vertex. And this is the y-intercept. Okay, what other points are we really interested in here? How about the zeros? To get those, we'll use the formula negative b plus or minus the square root of b squared minus 4ac over 2a. All right, there's going to be two of them now. Our b is 4. A is negative 1/2. And c is negative 2. Okay. According to the calculator, I get 0.54 and I get 7.46. Now these are, of course, approximate, though. Didn't come out to exactly those numbers, so I'm just going to use the squiggle line there. And these are the zeros. All right, so let's plot those points. Okay, so that's a lot of information. I can definitely start to sketch the curve now, but if I want to be just a little more precise, I may plug in some of these other x values and get outputs for them. So let's try plugging in an x of 1. Okay, I get 1.5 there. So this would be a point on our parabola. Let's try an x of 2. The output is 4 now. Okay. And let's try an x of 3. 5.5. Okay, beautiful. Now, if I were to plug in an x of 5, I already know what it's going to be by the symmetry of the parabola. It's going to be 5.5. And because this axis of symmetry is kind of like a mirror here, I could go on to sketch other points simply by reflecting the points across that axis of symmetry like a mirror. Okay, great. Let's put it all together if we can. into a smooth curve if possible. Not too bad. Our parabola keeps going forever, really. So we should put those arrows on there to indicate that. Let's go ahead and label it f of x. And we can label the coordinates of the vertex. That is 4, 6. The vertex was this row right here. And we could label the zeros too. There's a 0 at 0.54, 0. And this 0 is 7.46, 0. They both have output values of 0 because they are neither above nor below the x-axis. They're right on the x-axis, so their y values are 0. And it looks pretty good.